So we did the graphing part. The next two lessons we do the dealing with expressions part, which means simplifying. And simplifying also means add, subtract, multiply, and divide. But when it comes to rational expressions, actually the adding and subtracting are the more difficult, because when you add or subtract rational expressions, just like when you add or subtract fractions, you need a common denominator. That's a level of complication you don't have to deal with when you multiply or divide. So the first lesson is multiplying and dividing and simplifying. And then the next lesson is the add and subtract. So these are the steps in simplifying rational expressions. Factor the numerator and denominator, cancel the common factors. And this all relates to, fractions of numbers. How do you simplify a fraction like 15 over 65? You recognize that both the numerator and the denominator have a common factor, right? And I can write it like that, 5 times 3 divided by 5 times 13. And then because 5 is a factor of the numerator and denominator, I can cancel the 5s, right? Cancel, and I'm left with 3 over 13. We're going to be doing the same thing, but now it's not numbers. We've got variable expressions in the numerators and denominators. So in this example here, I do the first step. I factor the numerator and denominator. And because there is a common factor of x plus 3, I cancel it. The mistake that we make sometimes is that, if you're looking at this here, you can't do things like cancel the x's here, right? Because they're not factors of the entire numerator and denominator. Or I can't factor out a 3 of the 12 and the 5, right? 12 and 15. 12 and 15 are not factors, and 3 is not a factor of the entire numerator, entire denominator. So sometimes we do that, and really when we do that, we're kind of apples and oranges wrong. We're not just a little bit wrong, we're just completely the wrong direction at all. I mean, it would be like taking this 15 over 65, right, and say, let me write it as 10 plus 5 over 60 plus 5, and then cancel the 5s. You can't do that, right? You can go ahead and do the decimal, 15 over 65 and then 10 over 60, and you'll see they're not the same. You change the value if you just take away terms. So cancel common factors. I've got to be in blue. So simplify. Again, what is the first step that you just wrote down, Emma? Factor. Darn it. Try this again. It is not. There we go. X plus 5 times x minus 3 divided by x plus 3 times x minus 3. So that was step 1. Second step, cancel common factors. What is the common factor? X minus 3. So I cancel. And I'm left with x plus 5 over x plus 3. I'm going to add one little piece that I didn't do in the same order in the last class, but what would you say is the domain of that? Say again? X equals negative 3? Not quite right. x does not equal -3 is the domain, right? But that's actually not the entire domain. The domain, you have to, before you canceled that factor there, you have to take into account domain. The domain was actually x does not equal -3 or 3. Even though at the end you canceled out the x minus 3. If you remember in the last class, I showed one of the graphs where actually there was a common factor in the numerator and the denominator, and we canceled them out. In the end, on the graph, that didn't look like a vertical asymptote. It was a hole in the graph. So there's still going to be a discontinuity in the graph. It's not defined at either 3 or -3, right? Not just the simplified form. You got to look back up to before you started canceling factors. So generally, you're looking in denominators still. The zeros at the denominator are not in the domain. Okay, try to do that one. Factor and cancel common factors. Did you factor the numerator? What was the greatest common factor? Numerator. Come on. Greatest common factor between 40x and 20. 20. So it's 20 times 2x plus 1. Okay, how about the denominator? Greatest common factor is 10 times x plus 3. Okay, now you could probably simplify it without factoring those numbers. I mean, if we did it just because that's the way we're doing things now, I could write that as 10 times 2 times 2x plus 1 divided by 10 times x plus 3. And so there's another factor to cancel there, right? 10. So this is 2 times 2x plus 1 divided by x plus 3. And what is the domain? X does not equal -3. That seems to be our domain like half the time. Try that one. Factor, cancel common factors. It tended to be like overly hard. We don't want to get stuck on the factor and we're trying to learn about rational functions, right? But some of these patterns, like x squared minus 16, that's supposed to be just like almost trivial, you know, that's difference of squares. How does it factor? X plus 4x minus 4, right? You don't overthink it. So x plus 4 and x plus 4 times x minus 4. Okay, are there any common factors? Yeah, this x plus 4 cancels with this x plus 4. Okay, now when you cancel a factor, what does it leave behind? It's 1, right? So it's actually, there's a 1 in the numerator and the x minus 4 is in the denominator. And if I was going to say the domain, I would have to say x does not equal 4 and -4, right? You got to go back up to here. Before you started canceling factors, all those zeros of the denominator are still going to restrict the domain. Try that one. So how does the numerator factor? X minus 3 times x plus 1. How about the denominator? X minus 3 times x plus 2. Right? What's the common factor? X minus 3. So this is x plus 1 divided by x plus 2. And x does not equal 3 or -2. Right? Those are coming from there. So this is one for me. partly because it's got more difficult factoring in there. I would say, I think I've said this before, but rational functions, or all the things related to rational, are usually some of the more difficult problems on the SOL. A lot because of factoring, because we're just not great at factoring, so factoring is just a step along the way here, but if you can't do it, it makes it a lot harder. But if there's 5 problems that deal with it, most of them the factoring is fairly easy. Sometimes you'll get one like this, which is the not simple, going to take me 5 steps to factor it kind of problem. Unfortunately, sometimes we look at something like that in the numerator and can't do that, but that's supposed to not be a hard factoring. How do you factor a numerator like that? It's the greatest common factor, right? Don't overthink it. If you can't think of anything else to do, just see, is there a common factor between 2x squared and 10x? Yeah, 2x, right? So, it's the greatest common factor problem. Don't make that the hard part of it. I know that's going to be a kind of a hard part of it. Although, honestly, when it comes to these rational expressions, it's actually a little easier, and I'll show you why. I mean, let's say I factor this numerator as 2x times x plus 5. The thing is, I know that it's very likely, not all the time, but it's likely that there's going to be a common factor in the denominator. What do you think that common factor is going to be? Probably x plus 5. So that I could just make a guess that one factor in the denominator is going to be x plus 5. And if I know that, and I know what it is when I multiply it all together, I can fill in the blank in that other set of parentheses. What does the other set of parentheses have to be? Right. If I multiply x times this first term, I should get 3x squared. So what is this? It's 3x. And if I multiply 5 times this term, I should get 5 plus 1. Now, there could be some minuses involved there, but in this case, everything's plus, so it's going to be plus. Now, just check to make sure that the middle term is 16x. If I FOILed these two, would I get 16x? 3x times 5 is 15x. 1 times x is 1x. 15 plus 1. Yeah, that's it. Now, if I didn't do that, I would have to go through the long process, right? 3 times 5 is 15. What are the factors of 15 that add up to 16? 15 and 1. So I would split this up. 3x squared plus 15x plus x plus 5. I would group the first two, group the last two. Oops. Factor each set of parentheses. So this is 3x plus 1 times x plus 5, which is what we got. We'd already kind of figured that out. Now, cancel the common factors. And what's left is 2x divided by 3x plus 1. And what is the domain? X does not equal negative 5 and negative 1/3. Right? That comes from there. Now, having said that, I know that one of the homework problems, to simplify, when you factor everything, it turns out there's not any common factors. So it was actually in the simplified form. But you won't know that until you factor it. Okay, I think we're up to multiplying now. So if we multiply rational expressions, then these are the steps. Do you notice my little pointer there? Pretty nice, huh? Factor the numerators and denominators. So it could be even more than two fractions, right? It could be 3, 4, it's usually 2. So there's going to be more than one numerator or more than one denominator. Factor them all, if they're factorable. and then cancel the common factors. Meaning, even before you've multiplied them together, remember, you can cancel factors that are common to the numerator and denominator. And then once you've done that, multiply them all together. You know, if you want, you could just multiply them all together at the beginning. That's fine. You can really do it in any order you want, but I tend to factor first and cancel first so that I have less things to multiply together. But you could do it any way you want. And I say, you know, leave it in a factored form. The book is inconsistent. Sometimes they do, and sometimes they don't. Most of the time, since you already factored everything, everything is going to be in a factored form, and that's usually okay to leave it like that. Good. Good. Okay. Next. So, this one for me to do. Multiply. So, first step, factor all the numerators and denominators that you can. How does this the first numerator factor? What's the greatest common factor? 3x times 1 minus x, right? And how about the denominator? Factors of -5 that add up to 4. One's got to be positive, one's got to be negative. Emma? -5 and +1? +5, right? Because it's a +4 in the middle. It must have been x plus 5 and x minus 1. Multiplied times, factor this numerator. Factors of -20 that add up to 1. X plus 5, x minus 4. What about 3x? Can you factor 3x? No. Remember, factoring is what you do when you have more than one term, right? In all of these expressions here, there's more than one term because they're separated by pluses and minuses. That's one term. There's nothing to factor, right? Which is good, right? But so don't struggle over that. There's nothing to do there. Just write 3x. Okay, now cancel common factors. And it doesn't matter if they're in the same fraction or not. So what do you see that's in common? 3x cancels here. Just a second. I'm trying to change my color a little bit. Right, so here's 3x cancels with 3x. What else? X plus 5 cancels with x plus 5. What about 1 minus x and x minus 1? Do they cancel? They're not the same thing, but what's the relationship between them? I mean, I always use the example of, what is 3 minus 1? What is 1 minus 3? -2. They're opposites, right? Whenever you have just reversed the order of subtraction, these are opposites. So what do you get when you divide a number by its opposite? -1. So I can cancel these two. Just make sure I leave a -1 behind. And that is the way I would usually do it. I would cancel them and then just say -1. Okay. Now what's left? I think we've canceled everything that we can cancel. We have x minus 4 and we have a -1. So this is negative x minus 4, which is -x plus 4. Now, what is the domain? which values can x not have. In fact, we canceled the denominators, right? There's nothing left in the denominator other than a 1. But remember, you got it before you started canceling. That's where you say the domain. So x does not equal -5. X does not equal 1. X does not equal 0. There you go. So since there's more than one fraction, you got to check more than one denominator. So try that one. Did you factor the first numerator? 2x times x minus 5. How about the denominator? Times. Nothing to factor. Not that there's not two terms. There is, but there's no common factor. And 2x squared. Okay, what can you cancel? So this cancels with this. What else? X minus 5 cancels. What else? Well, the 2's cancel. And now you've got 1x in the numerator, and you got 2x's in the denominator, so cancel this x with one of these, and what's left? 1 over x. Done. Right. What is the domain? X does not equal -5, 5, and 0. Check both denominators. Good. Good. Now these are also problems we make a lot of mistakes with, right? Because of that first step, right? The first step says factor the numerators and denominators. Okay. How are you going to factor those? What is there to factor? How many terms are there in the numerator here?
3.
Just one, right? There's only one term in all of these. There's nothing to factor, right? Remember, factoring means there's more than one term separated by pluses and minuses. There's only one term. So there is no factoring to do. Don't be confused by a problem that actually doesn't have any factoring to do. I mean, we did this in the last couple, that there was at least one numerator or denominator, like this 2x squared. You couldn't factor it, so don't, right? Here we just have all of them have one term. Now, I would say I probably wouldn't do what I said under the directions, which said factor and then cancel between terms, just because to me it's kind of confusing because there's actually x's in 4 different places and y's in 4 different places. I think I would let's just multiply everything straight across and use properties of exponents to simplify a little bit. Like if I multiply the numerators here, I'm going to get 18, and then x to the 5th times x is x to the 6th. Y squared times y squared is y to the 4th. In the denominators, 8 times 9 is 72. X times x to the 3rd is x to the 4th. Y times y is y squared. Okay, now we've already put everything into the same fraction. Simplify. How about 18 over 72? 1/4. So it's going to be 1/4. How about x to the 6th over x to the 4th? X squared. Okay, 6 minus 4 means you got 2 left. How about y to the 4th over y squared? Y squared. There you go. So don't be confused. If you don't have any factoring to do, then you just don't do any factoring. What is the domain? There? It's not. It's just like these straight dots that I tend to create, but it doesn't make, it is a multiplication that's going on between those two. What is the domain? Before I started canceling things, this is what I had. X does not equal 0. Y does not equal, there you go. Yeah. Get rid of all these stray marks. And then I can say X does not equal 0, Y does not equal 0. Which I think leads us to dividing. Dividing rational expressions. In order to divide rational expressions, which are fractions, you have to remember, how did we divide fractions? You divide fractions by multiplying by the reciprocal of the second fraction, right? A over B divided by C over D is A over B times D over C. Take this and flip it. Right? Don't change the first fraction, just change the second fraction. And at that point, you just turned it into a multiplication problem, and we already have steps for that. And that's what these are. These are the same steps we use for multiplication. So change division problems into multiplication problems. Now, it does complicate domain, because how many different denominators do you have to worry about here? I mean, just looking at this problem right here, obviously I can't divide by 0 here or here, so I would have to check the two denominators that I start with. But actually, this is a divide too, right? So I have to make sure that C doesn't equal 0, because if C equals 0, this whole fraction equals 0, and then I'm dividing by 0. So I don't just check the two denominators, I've got to check the two denominators and the numerator of the second fraction for the domain. None of those can equal 0, or else we would have an undefined situation. So all these here, you got to check. We can't let any of those equal 0. All right, fine. So divide. What's the first step of dividing? By. Yeah, so my first step, I'm going to write this like 7x over 2x minus 10 times x squared minus 11x plus 30 divided by x squared minus 6. Then factor, right? 7x has no factors. 2 times x minus 5 times, how does x squared minus 11x plus 30 factor? The factors of 30 that add up to negative 11. 6 and 5, but they're both negative, right? Yes, I was looking at that going, what's the matter with this? Okay, how do I factor x squared minus 6? Okay, take out the x. Okay, cancel common factors. What do you see in common? X minus 5 cancels with x minus 5. X minus 6. The x's cancel. Anything else? I think that's about everything, isn't it? So this equals, this whole thing boils down to 7 halves. But it still has a domain. And what is that? I mean, it's all actually kind of a silly. Would it be accurate to say x does not equal 5 or 6 or 0 for the domain? But clearly it doesn't, because the whole thing equals 7 halves, right? So there's actually nothing to plug in an x for. But that is the drill that we go through for this. X does not equal 5, 6, or 0, right? And that comes from here, and here, and here. Almost done. I think there's one more, one for you to try. You try. Any questions about it? It looked like everybody was getting it. So that was it. Simplify, multiply, divide. Really? Thanks.